Welcome to RWG. Originally established in 1990 as a joint venture between Rolls-Royce and Wood Group, RWG has played a major role in supporting the energy market globally. Central to this activity is the Engineering and Component Technology Division, operating from its headquarters in Aberdeen, Scotland. In December 2014, the Rolls-Royce 50% share of RWG was sold to Siemens. The division comprises two self-contained state-of-the-art facilities, providing 40,000 square feet of floor space dedicated to the refurbishment and overhaul of components employed in RB211, Avon, Olympus, Rolls-Royce 501, 570 and Marine engines. Our extensive technical knowledge and experience acquired over many years ensures that refurbished components meet the same performance and reliability standards as new components and are supplied at a significantly lower cost than new parts. Let's take a look at how your components are refurbished at RWG's Engineering and Component Technology Division. At receipt inspection, all components are coded to ensure full traceability as they progress through the refurbishment process. Components are fully cleaned of corrosion products and coatings stripped in our cleaning line using environmentally friendly aqueous-based cleaning systems in line with our ISO 14001 Environmental Management Accreditation. Non-destructive testing is carried out and parts are inspected for cracks and defects prior to disposition. Components are carefully measured in order to ascertain the levels of refurbishment required. Here, an RB211 honeycomb seal segment is being subjected to CNC milling in order to recreate worn dimensions and geometry prior to brazing, EDM machining and sintering. This honeycomb is prepared prior to being welded to the backing plate of an RB211 seal segment. Once welded, the segment moves on to the sintering process. This involves filling the honeycomb cells with aluminium powder and heat treating under an argon and hydrogen gas atmosphere. This results in a fused aluminium layer of metal in the honeycomb cell, giving it strength and rigidity in service. High temperature brazing is carried out in our vacuum furnace. The vacuum furnace is also approved to carry out recovery heat treatments on superalloy materials such as turbine blades and nozzle guide vanes. This is known as solution and aging heat treatments to recover the mechanical properties after engine running. An Avon transfer tube is having its diameter reclaimed as wear and frettage are removed using the cylindrical grinder. An RB211 front combustion liner is having the outer wall welded back into position after the main body has been repaired and the thermal barrier coating renewed. This RB211 DLE combustion support is being welded to recover frettage, wear and cracking and restore the component to the original dimensions. Hard face material is also applied on turbine blades in order to enhance wear and oxidation resistance. As the Engineering and Component Technology Division also supports new manufacture for Siemens, here we see this process also being applied to a new single crystal Avon 200 high pressure turbine blade. This inert gas chamber enables us to weld various components under an argon atmosphere. This Avon inlet guide vane is having the leading edge welded to recreate the geometry after machining and dressing. Our circumferential welder is used to repair the journals and side faces of inlet guide vanes. These components are then machined back to the new production tolerances on the cylindrical grinder. RWG carries Siemens approvals for all repairs and processes. On completion of welding, components undergo heat treatment. The process time and temperature of all components undergoing heat treatment is monitored by our Experience system. This data is fully retrievable. Advanced metallic coatings, thermal barrier coatings, abradable linings and hard face coatings are applied by our thermal spray cell. Here we see the application of an abradable coating onto an RB211 high pressure casing using the plasma system. Tungsten carbide coatings are here being applied onto Avon inlet guide vane journals using the high velocity oxy fuel system. We have the capability to apply a wide range of specialist aerospace coatings, providing protection in the harshest environments. This selection of components from across the engine range have been coated with various proprietary protective systems. This Avon pin retaining ring is being selectively plated using electrolytic solutions. Worn bearing journals and this Avon compressor shaft are refurbished with nickel cobalt and top coated with copper plating. After plating, the journals will be machined to size. Machining is carried out on coated and uncoated components using a wide range of equipment. Complex machining can be carried out on a 6-axis CNC milling machine. On the vertical borer, the RB211 high-pressure compressor casing requires final machining after plasma spraying. Fine tolerances are required to achieve maximum compressor efficiency. Components are inspected at all stages of the refurbishment process, from receipt through interoperation to final inspection and dispatch, ensuring that all operations have been applied and the component has been processed correctly and machined to exact dimensions in accordance with the relevant repair scheme instruction. Our coordinate measuring machine is seen here calibrating an RB211 IP turbine blade interlock inspection fixture. Our highly experienced team of repair engineers develop component repairs, production engineer the repair on the shop floor, and deliver the first off-repaired component. This then undergoes the FAIR, or First Article Inspection Report process, which is subsequently approved by RWG Engineering Technical Authority and Siemens. One of the key parts within the gas generator is the turbine blade. RWG Engineering and Component Technology Division is the industry leader worldwide with over 7,500 turbine blade sets successfully refurbished to date. High-pressure turbine blades frequently need to be refurbished as a result of service running, leading to a variety of conditions. After a full strip of all oxidation and corrosion products and protective coatings, the blades are then subjected to non-destructive testing and inspected for cracks prior to disposition to determine the extent of repairs required. Refurbishment involves the application of the latest generation of proprietary weld repair techniques and alloys to the interlock and abutment faces of turbine blades. Our turbine blade oxidation-resistant hard-facing material has been proven consistently to deliver superior performance and significant increases in time between overhauls for engines used in all fields of operation. Prior to welding, the blades are subjected to the use of our proprietary recovery heat treatment process to fully recover microstructures back to the as-new condition. This important stage is vital to the refurbishment process and is carried out as standard on all turbine blades. In order to reinforce RWG's technical competence in recovery heat treatment, we embarked on a major verification study using RB211 superalloy high-pressure turbine blades. This test study involved engaging the services of a major international independent aerospace testing laboratory. Samples displaying advanced microstructural overaging were subjected to our proprietary recovery heat treatment process. Samples were then subjected to microstructural analysis and stress rupture testing. The test laboratory produced a comprehensive report on each material detailing microstructure recovery patterns versus stress rupture values. The reports concluded that microstructural analysis, stress rupture data, and statistical analysis clearly demonstrated that the engine-run material was indeed fully recovered back to the as-new condition. Our recovery heat treatment process is supported on-site by our dedicated materials laboratory, which undertakes microstructural assessments and creep void analysis where appropriate. Final machining of turbine blades is carried out on the creep feed grinder to achieve finished dimensions of the interlock and seal fins. This is followed by the reapplication of platinum and aluminide proprietary protective coatings. The final overhaul stage for turbine blades involves measurement of all dimensions to ensure blades are within exacting specification. RWG has a long track record of using this turbine blade overhaul process. This experience has led to RB211 turbine blade sets now being put back into service with over 100,000 running hours. RWG's Engineering and Component Technology Division is fully equipped to deliver high-quality component refurbishment for all your gas turbine components. Continuous investment in this division by RWG means that 90% of components requiring refurbishment can be achieved in-house. With more than 2,700 gas turbines having been overhauled by our engine facilities, we've earned a first-class reputation for quality, achieved with the excellent support from the Engineering and Component Technology Division. Our component technology team continue to push the boundaries of component refurbishment, looking at new processes, new technology, and new investment opportunities to maximize component recovery. Every new technical instruction developed by our mechanical and metallurgical engineering teams at RWG is fully validated by our materials laboratory prior to approval by Siemens. Our repairs provide extended life to your parts without compromising their integrity. You can rely on RWG to deliver. RWG, repair and overhaul expertise.